Hello Year 12 and welcome back to Maths, and we are going to look at using integration today, 11.4 from the book. Okay, the Pete Hart video on your PowerPoint goes through the two examples, and I'm going to look at some questions from exercise 11D, including the challenge question, and I'm going to set some of this work for you to have a go at home and send to your teachers for checking. So, using integration. This, remember, chapter 11 is all about variable acceleration. So we cannot use the Suvat equations when the acceleration is changing. Now, to get from displacement to velocity, last lesson we looked at the fact that you differentiate going down, and from velocity acceleration you differentiate. If we're going the other way, the opposite of to differentiate is to integrate. Okay, this little diagram here is fundamental to chapter 11. So keep that in mind the whole time. Displacement S, velocity V, acceleration A. So let's look at some questions from the book. So the first question we'll look at, the most simplest question from chapter exercise 11D on page 189. So let's say, for example, you're given the velocity v of a particle moving on a straight line, and you're told at time naught the displacement moved is 0. And it asks you to find S, the displacement moved, or an equation or an expression for the displacement moved. Now, we know that ds over dt is equal to v. So I can say the opposite. I can say if I integrate v with respect to time, I will get s. Okay, remember going back to this here. If I integrate v, I get displacement. If I differentiate displacement, I get velocity. So, using that fundamental idea, I'm going to start off. I'm just choosing what colour I'm going to use. I do like my new colours. I hope you like them too. Liven up the lesson a little bit. Okay, so I'm going to integrate 3t squared minus 1 with respect to t. Okay, and that will give me my displacement using this formula here. Right, so integration. How do I integrate? Well, I add 1 to the power and I divide by the new power. Constant will go, minus 1 will go to minus t. Now remember, with integration we always have this constant of integration. Now we can find that constant of integration by putting in this here. We know that when s is 0, t is 0. So if I put t equals 0 into this equation, I can see that when s is 0, t is 0, so my constant is 0. So therefore my expression just becomes this. The 3's cancel, my c is 0, and this will be my answer. Right, what I'd like you to do now is question B. It's exactly the same. Just check your understanding of that. Pause the video, have a go, and I will go through it once you've unpaused it. Okay, well done. I'm sure you've all got that correct. So what we do is, to get S, we have to integrate V. So we have to integrate this expression here with respect to time. Now remember, we must write that down, but it just, all it's saying is we're integrating what's here. You might want to put brackets there to show that we don't actually do anything with this dt. It just means we integrate with respect to t. Okay, so to integrate, add 1 to the power, divide by the new power. Keep this fraction here, add 1 to the power, divide by the new power, plus my constant of integration. Okay, I can see that my 3 would cancel here. I can see 2 will go into 4 2 times, just simplifying. I'm going to put in, when s is 0, t is 0. It was always the case for each of these equations, these conditions here. Again, I get c equals 0, so my end equation is this. Because c is nothing. Okay, pause the video, have a go at question C. Okay, so let's go through this one. So s equals the integral of 2. I'm going to change that square root to the power of a half, integrating with respect to t. Okay, how do I integrate? I add 1 to the power and I divide by the new power. Well, rather than dividing by 3 over 2, let's times by 2 over 3, the reciprocal. Okay, add 1 to the power, divide by the new power, plus my c. I can see, again, c is going to be 0 because when t is 0, s is 0. Won't always be 0, but just for these 3 it is. Okay, let's just tidy this up. So I've got 2 times 2, 4 over 3, put my fraction at the beginning, then my algebra, plus 4 over 3 t cubed. So there's my answer for part C. Okay, well done. Right, let's have another look now at question 2 together. Okay, question 2, you're given an equation this time for acceleration. You're given your conditions at the beginning and you're asked to find the velocity v. Again, we go back to this fundamental concept. We're given acceleration and we want to find velocity, so we integrate acceleration to get velocity. So velocity will be the integral. So basically exactly the same method as in question 1. So pause the video, have a go at doing that, and then just check your solutions. Okay, add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power, that's my constant. T equals 0, v equals 0, my constant will be 0. Tidy up, and I will have this as my solution. Okay, I'm not going to go through B, it's exactly the same as what we've just done. Right, next let's look at some harder questions. I'm going to leave you questions 3 to 6 to have a go at on your own. I'm at home and send to your teacher. I'm going to look at a harder question now, question 7. Okay, question 7 says find x when p is at rest. If we just find question 7 in the book, just read that through. A particle p is moving on the x-axis. At time t seconds, the velocity is this, in the direction of x increasing, i.e. moving along the x-axis in this direction. At time t equals 0, p is at the origin. Find the value of x, i.e. the displacement, at the instant when t is greater than 0 and p is at rest. So at t equals 0, p is at the origin and p is moving along the x-axis. Okay, so how do we go about this question? Well, we want to find a displacement from velocity. So first of all though, I want to know what is my value of t when p is at rest, i.e. when v equals 0. So let's put v equals 0 into here, and I want to find my value of t. Well, I have to factorise. So this shows me either t is 0 or t is 4. Now we know at the beginning when t equals 0, it's at rest, and then for the answer we want for A is t equals 4. And we're asked to find the displacement moved along the x-axis when it is at rest. So to find displacement, we have to integrate our velocity. So we have to integrate our velocity equation with respect to time. So let's integrate that. Add 1 to the power, divide by the new power, add 1 to the power, divide by the new power, and add my constant of integration. Now, you know at the beginning, t equals 0, s equals 0. So my constant of integration is 0. So I can ignore this c here. Okay, now I want to find the displacement s when t is 4. So I'm going to put 4 into this equation, and if you do that, you will get an answer for s of 10 and 2/3. So just put t equals 4 into this equation, use your calculator, and you'll get your solution for the displacement. Okay, part B. Find the total distance moved by p in the interval between 0 and 5. Now, it does have a little hint here, problem solving. You will need to consider the motion when v is positive and negative separately. So let's see what that means for this question here. Okay, so if I look at when t equals 5, I know that my displacement equation is this. Okay, so if I put in instead of t, if I put in 5, so when t is 5, I get this answer, 8 1/3. But when t was 4, this was the displacement. So what's actually happened, if I draw a little diagram to try and explain this, we're starting at the origin here. The particle's moving along the x-axis in the positive direction. At time 4 seconds, it's travelled 10 2/3 meters. What's happening then is it's travelling backwards, because at 5 seconds, in the next second, it gets to here, where it's the displacement s, remember s is displacement from the origin, is 8 1/3 meters. So it travels 10 2/3 meters, and then it comes back this way. So what is this distance here? Well, this distance will be 10 2/3 subtracted 8 1/3. So that whole distance there will be 2 1/3. So I hope all of that was on the page then, it didn't come off the video. Okay, so we travelled 10 2/3, and then we travelled another 2 1/3. So the total displacement travelled is 10 2/3 plus 2 1/3, which is 13 meters. So quite a difficult question, that question 7. Okay, you might want to have a pause now, have a rest, get a cup of tea. I'm going to go through questions for the rest of this video. What I'm going to do is I'm going to go through question 11, 12 and the challenge. 11, 12 and the challenge. If you want to have a go at 11 first before I go through it, please do. Or you might just prefer just to listen to me as I go through it. Okay, question 11. Again, you don't have to watch the video all in one chunk. You might want to split it up. It is quite a lot of thinking going on here. So question 11. A particle P travels in a straight line such that its acceleration is this. The velocity is given to be v at time t. When t equals 0, v equals 4. So it's already got a velocity at the beginning. Find v in terms of t. Okay, so to do this, we know that velocity is the integral of acceleration. So if I integrate, add 1 to the power, divide by the new power. Constant will go to 3t, plus my constant of integration. In this case, c won't be 0. If I put in this condition here, I can see that c will equal 4. So my equation will become t squared over 2 minus 3t plus 4. So that's my equation for v. That's a 2 there. Okay, part B. Find times when P is at rest. So to do that, we need to put v equal to nothing when it's at rest. So we're looking at this equation here is equal to 0. So we want to solve this. I'm going to get rid of this fraction by timesing each term. Remember to times every term by 2. Doesn't change the equation. Hopefully this will factorise. Yes, it does. I can see I'm going to get t, 4 and 2, and both will have to be negative to get my negative 6. So it's at rest when t equals 4 seconds and when t equals 2 seconds. And the last question says find the distance between these 2 points. Right, so we haven't actually come across a question like this yet, so this is new. Find the distance between these 2 points, so a slightly new concept here. Now I have got my velocity, and to get my velocity I need to integrate to get my displacement. So let's do that first. So S is the integral of velocity, and my velocity equation is, just go back, my velocity equation is t squared over 2 minus 3t plus 4 with respect to t. I can't use this equation here because that isn't equal to velocity. I must use the original equation for velocity, this one here. Okay, not this one because I have actually changed the equation there. Now, for this one, I know that I'm looking at the distance between the 2 points when t is 4 and when t is 2. So I'm going to put in my limits here between 2 and 4 rather than working out a constant of integration. And I'm just going to integrate this as I normally would. So add 1 to the power, divide by the new power, so 2 times 3 is 6. add 1 to the power, divide by the new power. And now I use square brackets, 4 and 2. I'm not going to continue the whole question here, but you're going to put 4 in, get a solution, put 2 in, get a solution. So if I put 4 in, I get that. If I put 2 in, I get 10 over 3. I take away the 2 answers and I will get minus 2 over 3. Okay, the negative sign, I mean obviously just distance can't be negative. The negative sign is just showing it's going in the opposite direction. But the distance, okay, and the question did ask for the distance between the 2 points. The distance will equal 2/3 of a metre, not negative 2/3 of a metre. That's just saying that that's the displacement, okay, which is the opposite direction to what my velocity was travelling. So it must be minus 2/3 away from the x-axis, rather going to the left rather than to the right. Okay, so that was question 11. Right, 2 more questions to go. Again, you might want to pause, have a go at 12 yourself. Here's 12, and then I will go through it with you. So, actually, I think 12 is actually quite simplistic. I don't think there's nothing new in question 12. I think I'm going to leave that, guys. I'll set that as part of your homework. If you struggle with it after looking at the solutions, I will then do a video on it for you. So actually I'm going to go straight to the challenge question. I haven't written this out, but let's have a look at it here. So making sure we do some of the harder questions as well, the really tough ones. Okay, so here's your challenge. The motion of a robotic arm moving along a straight track is modelled by these 2 equations. Got 2 equations now, and we're given a velocity time graph here. Work out the total distance travelled by the robotic arm. Remember, distance of a velocity time graph is the area under the graph. Remember that key concept that we did right back at the beginning of mechanics. Right, so let's just have a go at this yourself and then check your understanding with my video. So you've got this graph, and there's 2 separate graphs here. I've got my velocity and I've got my time. This is at time 10 seconds here. Now, for the first part of the graph, you've got this equation, and that's saying that's valid between t equals 0 and t equals k. And then you've got the second part of the graph here, and you've got this equation. And again, that is valid between k is 10 and k. And it's equal to k in both equations. So at the instant that time is k, i.e. at this point here, both these equations are exactly the same amount, exactly the same velocity. So I'm going to first of all use that concept to help me with this problem. So at time, so when time is equal to k, I'll put that t equals k into this equation, and it's going to be exactly the same solution when I put it into this equation here. Okay, so I can see I've got a quadratic equation now in terms of k, and I want to find what k is. Because once I've found what k is, I can then integrate this part of the curve between 0 and k. If I integrate velocity, I will get the area under the curve, which is displacement. Again, and then I can integrate between k and 10, this part of the graph, and I'll get the area under the curve. So if I integrate this, okay, between 0 and k, I'll get this part of the graph, which is equal to the distance. And if I integrate this equation between t is k and 10, I'll get the area under the graph, again, displacement s. Okay, so you can look at the solution bank if you're not sure how to solve this. You eventually get an equation that becomes 7k squared minus 4k minus 96 equals 0. Multiply everything through by 12. Unfortunately, it doesn't factorise, so you have to use the formula. And eventually you get down to this using the formula. Okay, now k has to be a positive solution. You cannot have negative time. So if I just look at the positive solution here, positive 52 plus 4 over 14, I will get my answer for k, which is 4. Okay, so I've got my value of k to be 4. So if I now integrate the first part between 0 and 4, get a solution, and add it to the second equation, if I integrate this between 4 and 10, if I get those two, I'll get the total distance travelled. So I'm not going to work all of that out. You can do that. If I do the first one, I will get 56 over 3. If I do the second one, I will get 48. If I put those two together, my end answer will be 200 over 3 meters. Well done if you did that on your own. If not, I hope you understand it now. Please email myself or your teachers any questions, and I am going to set you now some work to do from exercise 11D. So guys, the questions I would like you to do, and again I'll put this on your show my homework, exercise 11D, please do question 3, 4, 5, 6 and 12. Okay, exercise 11D, 3, 4, 5, 6 and 12. Email it to your teachers, please. Take care. Hope you're all surviving this lockdown. Make sure you get plenty of exercise, plenty of fresh air. Lovely to teach you again.